The unreasonable effectiveness of data. It sounds kind of academic, right? Well, it comes from a landmark paper from Google back in 2009. It's a nod to an old idea about the surprising power of math and physics. But in this story, the hero isn't some complex, elegant equation. It's just a mountain of data.
So, have you ever stopped to wonder about this? I mean, why are some sciences just so, well, messy compared to physics? Physics gives us these beautiful, clean formulas, right? Like F equals ma. They just work. But the second you try to model anything involving people, like economics or even language, it all gets incredibly complicated.
There's actually a name for this feeling. It's called physics envy. And for a long, long time, researchers in fields like AI and linguistics were basically chasing that same dream. They were convinced, absolutely convinced, they could find just a few simple, perfect, universal rules to explain something as wild and complex as human language.
And that brings us right to what you could call the old dream. This was the way everyone thought for decades, that true, deep understanding would come from discovering the fundamental grammar of language, its core operating system.
Yeah, the goal was to find those few elegant, universal rules for language, kind of like F equals ma explains motion. The thinking was, look, if we can just build these super complex, handcrafted theories and elaborate models, we're talking like a 1,700-page grammar book for English, we could finally crack the code. It was all very top-down, very theory first.
Think of it this way. This old way of thinking was all about surgical precision. It was like trying to calculate the perfect trajectory, the exact angle, the precise amount of force you need to throw a single dart and have it hit the bullseye. It required this really deep theoretical understanding of, the physics of dart throwing. And then everything changed.
And the change wasn't some brilliant new theory. Nope. It was a flood. A complete data deluge that was so massive it just completely changed the entire landscape of what was even possible.
Okay, to really get a sense of how big this shift was, let's just rewind a bit. Back in the 1960s, the absolute cutting-edge resource for language researchers was something called the Brown corpus. It had 1 million English words, and people were so excited about it. It was a breakthrough. So just lock that number in your head. 1 million. Got it? 1 million. Okay, now fast forward to 2006. Google releases a corpus of 1 trillion words. Let that sink in. That's not just a little bigger. That is 1 million times larger. It's not even the same ballpark. It's a totally different universe of information.
And here's the kicker. This new data, it was messy. I mean, it was scraped right off the web, so it was jam-packed with typos, bad grammar, you name it. It wasn't carefully curated or hand-labeled by a bunch of experts. But, and this is the most important part, its sheer overwhelming size made all those little imperfections totally irrelevant.
So this data deluge created a brand new reality. A reality where all the old assumptions about how to solve these problems got flipped completely on their head.
So what happened? The goal itself shifted. Instead of the old way, building these really elaborate, beautiful models to try and find general rules, the new reality was all about using incredibly simple models. I mean, dead simple. These models didn't try to understand language in some deep philosophical way. Nope, they were just fantastic at one thing, basically memorizing and spitting back statistical patterns from that gigantic pile of data.
And this right here, this is the central idea of the whole paper. It's the finding that has pretty much defined the last decade of AI. It turns out, time and time again, that simple models with a ton of data consistently blow more complex, smarter models with less data right out of the water. More data just beats a cleverer algorithm. And the reason why is that this ocean of data captures millions of real-world examples, all the messy edge cases, and all the subtle patterns that no human design model could ever possibly predict or account for.
Let's look at a really clear example to see how this works. The task was something called scene completion, basically photoshopping an object you don't want out of a picture and filling in the background. Okay, so when they tried this with a data set of just thousands of photos, the algorithm did a terrible job. The results were just garbage, totally unbelievable. But then, when they took the exact same algorithm and just gave it millions of photos to learn from, it suddenly worked pretty darn well. The algorithm didn't get any smarter, the data just got a whole lot bigger.
Now, this whole data-first approach can get a little confusing, especially when we start throwing around a word like understanding. So the paper makes a really important distinction here that helps clear things up.
Okay, so on one side, you've got the semantic web. Think of this as creating perfectly structured data so that computers can talk to each other flawlessly. like a universal, unambiguous format for a calendar date. But on the other side, you have semantic interpretation, which is the much, much harder problem of figuring out messy, ambiguous human language, the way we actually talk and write.
And this just illustrates the difference perfectly, right? Even if you have a perfect formal web standard for company name, you still have to figure out which of the hundreds of businesses called Joe's Pizza someone is actually talking about, or whether HP means Hewlett-Packard, the tech company, or Helmerich and Payne, the drilling company. And the only way to solve that kind of ambiguity is with context. And where does that context come from? You guessed it, massive amounts of data.
So all of this leads to a powerful new mantra for anyone working with data. It really points to a clear path forward.
Remember that first dartboard, the one where we needed a perfect physics equation to hit the bullseye? Well, this is the new reality. Forget the perfect equation. Now you have 1 trillion darts. You don't need perfect aim, you can just blanket the entire board. The sheer volume of data gets you to the target, even if the individual models you're using are super simple.
So, after all this, what's the big takeaway? What's the bottom line? The authors give us a simple, powerful, 3-word mantra that's basically a call to action. Follow the data.
And what does that actually mean in practice? Well, first, it means using the whole world of messy, unlabeled data as your source material. Don't be afraid of it. Second, it means trusting that language itself is pretty smart, that humans have already come up with words for the things that matter. And finally, it means seeing what you can do just by connecting the dots that are already there in the data, instead of trying to invent brand new abstract theories from scratch. And this leaves us with a really fascinating final thought. This whole principle that simple models plus massive data create this unreasonable effectiveness has already changed so much. So the question we're left with is this: if more data is almost always better, what new, seemingly impossible problems can we solve tomorrow if we just had a bigger data set?